Excellent. Greetings to all those joining us both in South Africa and internationally for the first seminar in a 10-part series on climate change. I'm Professor David Bilchitz, Director of the South African Institute for Advanced Constitutional, Public, Human Rights and International Law, SAIFAC, a center in the Faculty of Law at the University of Johannesburg. We are delighted to be the hosts of this series. Climate change is perhaps one of the most pressing global problems, and it hangs threateningly over our heads and the heads of our children and future generations. Addressing climate change requires, we have heard from the UN, leadership from all of us in making the required changes to our lives and our economic systems. It also requires human beings to work together for a common goal. I'm happy to say that this series is an example both of leadership and working together. The series was developed by a group of academics collaborating from across several universities in Johannesburg and across a range of disciplines. The organizers were struck with the need for leadership to find a way to contribute to the campaign to avert significant harms caused by climate change. In brainstorming what could be done, the organizing team recognized the need for greater public understanding around the multiple facets of climate change. The engagement around these issues is also rather limited in South Africa and Africa more generally, even though we are likely to suffer very serious effects from climate change. As academics, we have a responsibility to share information and reach across disciplinary and institutional boundaries. It was thus decided that we would create a series of seminars with leading experts, which would explore various aspects of climate change from the perspective of multiple disciplines. And hopefully that could help us achieve these goals. And so this 10-part seminar series will cover what climate change is, why it matters, and what must be done to address it. Through carefully designed topics, we will delve into science, law, policy, and social justice, and expose participants to the key debates that occur in these areas. I want to pay tribute to the multidisciplinary organizing team for their vision and leadership. They are Professor Kitty Dumont, Professor in the Department of Psychology at the University of South Africa, Dr. Jenny Hall, in the Department of Procedural Law in the Faculty of Law at the University of Johannesburg. You can all wave when I mention you. Professor Diane Hildebrandt, Director of the Institute for the Development of Energy for African Sustainability, IDEAS, at the University of South Africa. Professor Luwazi Ngubevana, Director of the African Energy Leadership Center at the Wits Business School. And Professor Colleen Fogel, Distinguished Professor at the Global Change Institute at the University of the Witwatersrand. I would also like to thank our partner Constitution Hill for their support and all those who have helped to advertise the series. From the SAIFAC side, I would like to thank Naomi Ho for her work on the administrative side and Ibrahim Karim for designing our posters. Tonight, we only have 100 places in the Zoom conversation and we had a fantastic response. So we're also live streaming on Facebook and welcome our viewers who are joining us on Facebook. You're also welcome to ask questions and this Facebook feed will be monitored as well. Our participants in Zoom can write their questions in the Zoom chat or put your name there or raise your hand when the question opens to ask a question orally. Our first topic tonight is what is climate change all about? Issues and implications for Sub-Saharan Africa. I also want to invite you to look at our schedule of other topics and to join us for our second seminar, which we are delighted will be delivered by Dr. Pali Lehochla, former Statistician General of South Africa. And he will deliver this on the 6th of May, so in 3 weeks' time, on the discomfort of uncertainty and the certain uncertainty of scientific research. We already have a top speaker lined up also for topic 3, which will address how do people and societies respond or not to climate change, navigating the complexities of human behavior. And that will be on the 27th of May of this year. And we have Professor Matthew Hornsey, Professor of Social Psychology from the University of Queensland Business School, who will deliver the seminar. If you are interested in any of this, I will post some information in the chat, but RSVP to naomi@saifac.org.za for the links. I will now introduce the chair for tonight's seminar, Professor Diane Hildebrand, who will conduct the event and introduce our outstanding guest speaker, Professor Francois Engelbrecht. Diane Hildebrand is the director of the Institute for the Development of Energy for African Sustainability, or in short, IDEAS, and a professor of chemical engineering at the University of South Africa, UNISA. She's a distinguished professor and the director of the International Joint Research Laboratory of New Energy at Hebei University of Science and Technology in China. Her research area is the design of energy efficient processes and equipment with a view to reducing carbon dioxide emissions from chemical processes. I now wish to hand over to Diane. Diane, over to you.
Thank you very much, David. And thank you again to SAIFAC for hosting this event. And thank you to all our listeners. We hope you find this an interesting and informative event, and certainly we hope it's thought-provoking. We're very pleased. Our first speaker, Professor Francois Engelbrecht, is a distinguished professor of climatology at the Global Change Institute at the University of the Witwatersrand. He specializes in climate modeling development and the simulation of African climate variability and change, and currently leads the development of an African-based Earth system model. Prof Engelbrecht's research has led to new insights into the changing temperature, rainfall, and circulation patterns over the continent under anthropogenic forcing. He served as an invited lead author of the IPCC Special Report on Global Warming of 1.5 degrees, which was published in 2018, and currently serves as an invited lead author of Assessment Report 6 of the IPCC. He's an invited member of the Working Group on Numerical Experimentation of the World Change Climate Research Program, co-chair of the World Meteorological Organization's Joint Expert Team on Earth System Implementation, and a scientific steering group member of CLIVA of the World Climate Research Program. We are very thankful that you could talk to us tonight, Francois, and look forward to your talk. Thank you.
Thank you, Professor Hildebrand, for the introduction and the engagement over the last 2 weeks, or a bit longer, I think, towards setting up my talk today. I am presenting everybody here from the Global Change Institute at WITS. I'm still in my office, and if you listen carefully, you will hear in the background the noises of Braamfontein at sunset. What I'm going to do is to switch off video and share my screen, and then I'm going to jump straight into our first presentation. So I'm going to talk today about climate change, what it is, what is the physical science base behind climate change. And I'll do all of this through the lens of climate change in Sub-Saharan Africa, our part of the world. Let me jump straight into the discussion by showing to you this quite remarkable map. It shows temperature anomalies back in the summer season of 2015-16. I'm speaking about December to February, of course, the Southern Hemisphere summer. And I guess many people in the audience will remember how exceptionally hot that summer was. And this map, in fact, confirms that the areas in dark red are those parts of the world where the all-time temperature records were broken back in the summer of 2015-16. And you can see that in our region, Southern Africa, almost every single weather station broke its all-time record in terms of the average December to February temperature. Now, 2015 at the time was the warmest year ever recorded by humans. The year 2016 was even warmer, and it remains until today the hottest year ever recorded by humans. Measurements go back to 1850, by the way. 2015 is also important in the context of global climate change mitigation, a topic we will also address today and certainly also over the next several months through this seminar series, because 2015 is the first year during which the world's average temperature was 1 degree Celsius higher than the so-called pre-industrial temperature. So 1 degree Celsius higher than the natural temperature of the planet. And in my talk today, I'm going to explain why that is so important and why 2 degrees Celsius of global warming has been regarded for a very long time as being the threshold signifying dangerous and irreversible climate change. Nowadays, of course, there are scientists that think that that threshold may sit at 1.5 degrees Celsius of global warming, but we will get to that. Let me lastly point out some other remarkable features in that map. If you look to the south of Greenland and to the north of the Antarctic Peninsula, you will see parts of the world that were exceptionally cool during that summer of 2015-16. So while the rest of the world was experiencing the warmest years at the time in the historical record, those parts of the world were exceptionally cool. And I often ask my students to think what the reasons for that may be, and usually they are quite correct by managing to argue that it must have something to do with the fact that in a warmer world, there's more glacier melt from the Greenland ice sheet and Antarctic ice sheet. And of course, that fresh water, that cold and fresh water lingers close to the surface in those parts of the world. There's more to it than that, but let me not go deep into that specific aspect of that exceptionally hot summer. Now, an important reason why the year 2016 remains until today the hottest year ever recorded by humans is because it also occurred in association with the biggest El Niño event ever measured. So on this map, currently on the screen, you can see the above normally high sea surface temperatures in the Central and Eastern Pacific Ocean. That was towards the end of 2015. And the El Niño event, as the climatologists and the geographers in our audience today will know, brought to South Africa what it usually brings to South Africa, namely drought. And in fact, during the summer of 2015-16, the Free State and Northwest provinces of South Africa recorded their driest summer in the historical record. And that photograph you can see on that slide is of a dust storm. It's a photograph I took while driving close to Kroonstad. That was back in December 2015. So it was an exceptionally devastating drought across Southern Africa. In South Africa, our maize crop was in the order of 30% higher, lower than the previous year. And in Botswana, Botswana lost about 20% of its cattle in 2015, and another 20% in 2016. So it is now certainly one of the most devastating droughts on the record for our region, Southern Africa. So as you may have deduced, I'm busy giving some background information here. I'm talking about climate variability in Southern Africa, but in the context of these very warm years we've been experiencing in recent years. Let me press on with this narrative. 2019, there you can see the map. In this case, these are showing annual average temperature anomalies for the entire year of 2019. Now, 2019 is the third warmest year on record. And you will see that our entire western half of our region, the entire western half of Southern Africa, experienced its warmest year in the historical record. Now, this is another pattern I would like to emphasize in the talk today. You will soon see this pattern. Even during years that are exceptionally hot globally, we also, during such years, tend to find really record-breaking years in Southern Africa. So there's something quite unique about temperature change in Southern Africa if we compare it to almost any other part of the Southern Hemisphere. I'll get back to that. For now, let me also just point out that the warmest 10 years ever recorded by humans are the last 10 years. So we are most certainly living in the days of global warming. And I will talk more about what's causing this warming and what it means for our region. So further on this quest to provide you with some background on climate variability in Southern Africa, on this slide, you can see another absolutely devastating event that occurred in this part of the world. The slide shows the landfall of tropical cyclone Idai. It occurred almost at midnight on the 14th of March, 2019. That's now the landfall of the system. You can see the eye of the cyclone on that slide. And you can see that landfall occurred almost exactly at Beira in Mozambique. Now, colleagues, I think too few people realize even today that this is the most devastating flood event in terms of loss of life that have ever been recorded by humans south of the equator. So in our entire historical record, we've never experienced something like tropical cyclone Idai. In the end, it is now estimated that more than 2,000 people lost their lives in the flooding and the storm surge of this tropical cyclone. The storm surge is, of course, that wall of water that develops around the eye of the cyclone and then, under certain circumstances, move inland. So just in Beira alone, several hundreds of people died because of that massive storm surge that overwhelmed Beira in the early morning hours of the 15th of March, 2019. In the end, the storm affected Malawi, Zimbabwe, Madagascar, and that is where we've experienced the devastation and all these losses of life. That's how it looked just after the storm. So it literally happened that an inland lake formed inland of Beira in the wake of this storm. So remember, tropical cyclones can cause hundreds of millimeters of rain and easily, in some cases, 1,000 millimeters of rain over a few days, over the areas that they move into. So tropical cyclone Idai just pointed out to us again how vulnerable Sub-Saharan Africa is when extreme weather events strike. Remember, in our part of the world, we just don't have the infrastructure to protect us against extreme storms. For example, there's no seawall at Beira. There's no seawall at Maputo or at Richards Bay. So when an intense tropical cyclone strikes, we have very, very little protection against the storm surge. And we have a bad transport infrastructure in many parts of Sub-Saharan Africa. So the early warnings coming from numerical weather predictions were arriving timelessly about 3 days ahead of landfall of this storm. We knew that the storm was going to hit at Beira, but it was just not possible, or there was some obstacles that prevented the 500,000 inhabitants of Beira to be evacuated in time. So I think that the big drought of 2015-16, the Cape Town drought of 2015-17, and the landfall of tropical cyclone Idai in 2019, all these extreme weather events need to make us think very, very carefully about how vulnerable we are in Southern Africa when these types of events strike. And we need to have a very, very careful look at climate science in terms of what it can tell us about the role of climate change in these storms. Now, I will also get back to this later on in the talk, but let me mention for now that there is, of course, evidence from across the world that the number of intense tropical cyclones are increasing. And that is also the case in our part of the world, specifically what we call in climatology the Southwest Indian Ocean. And the last bit of background I'd like to give in terms of natural climate variability in Southern Africa is just this slide that summarizes it all. On the y-axis, you can see sea surface temperatures in the tropical Pacific Ocean. That is what we use to measure the presence of El Nino events when the Pacific Ocean is experiencing above normal temperatures in the central tropical parts. And on the x-axis, we have rainfall anomalies recorded in South Africa's Free State and Northwest provinces. Now, the relationship is quite obvious. If you look at the upper left part of the graphic, you will see that usually when the Pacific Ocean is warm, we are experiencing below normal rainfall in the summer rainfall parts of these two provinces, but in fact that holds for almost the entire Southern African region. So you can see that the red dot there at the top, that represents the warmest year ever recorded, the strongest El Nino event ever recorded, 2015-16 El Nino. And you can see on the x-axis that was also the driest year on record in these two provinces. Now, the opposite is also true. If you go to the lower part of the graph, when the Pacific Ocean is experiencing cool conditions, then you can see that those cool conditions usually bring above normal rainfall to Southern Africa. So it usually works like this. When the Pacific Ocean is warm, South Africa experiences below normal rainfall conditions. And when it is cool, South Africa experiences good falls of rain, but unfortunately, in some cases, also flooding, and specifically landfalling tropical cyclones. That's the general rule. It doesn't work like that with every single El Nino or La Nina event. But I think this provides every one of you with, who are not climatologists with the necessary background needed for the rest of this talk, which is about climate change and its impacts on the Sub-Saharan African region. So let us start to systematically discuss climate change. So we have this variability that occurs from one year to the next. But if we look at the long-term records of rainfall and temperature in Africa, we can also identify systematic trends that have been manifesting in the African climate system over the last several decades. Now, in climatology, we always start by considering perhaps the simplest of variables in terms of understanding, for which there's also reliable measurements available, and that's, of course, temperature. Now, in this specific slide, you can see the recorded rate of temperature increase in Africa. The units there in the color bar are in degrees Celsius per century. And what you can see is that in the Southern African region, let's start with South Africa. There you can see that the rate of temperature increase in the east is in the order of 2 degrees Celsius per century. And in the west, it's a bit higher. Over northern Botswana and southern Zambia, the recorded rate of temperature increase is a staggering 3.6 degrees Celsius per century, even reaching 4 degrees Celsius per century in some of those regions. And also, if we look at subtropical North Africa, we see the same high rate of temperature increase. Now, this is the next important message I'd like to convey tonight, and I will speak to about this more. But it is extremely important to realize that in Southern Africa, and in fact in much of Sub-Saharan Africa, temperatures are rising at about twice the global rate of temperature increase. Remember, in 2050, the world was 1 degree Celsius warmer than its pre-industrial average. Across the interior parts of Southern Africa, large parts of Africa south of the equator, but outside the tropics, the observed temperature increase is already in the order of 2 degrees Celsius. So why is this happening? Why are we living in the days of global warming, and why do we see these regional manifestations of warming in our part of the world? Well, I trust everybody in the audience know, of course, that this is the consequence of the increases in greenhouse gas concentrations in the atmosphere. And in particular, the increase in carbon dioxide that has resulted all the way, well, that is the result of the burning of fossil fuels in the first place, and the burning of coal and oil. And of course, that really started at the time of the Industrial Revolution in the early 1800s. Now, as we meet here today, the observed increase in carbon dioxide concentrations in the atmosphere as compared to the natural conditions is already in the order of 40%. You can see on the thick black line of that graph, which shows the projected growth in carbon dioxide emissions according to a low mitigation, so-called low mitigation scenario. So if we continue to rely largely on the fossil fuels as our main source of energy globally, you can see that carbon dioxide concentrations will double their natural values more or less by the year 2050 and approach very, very high concentrations towards the end of the century. Now, the other type of scenario is represented by the red line in that graphic. That represents the successful implementation of the Paris Agreement on climate change. And in that case, you can see how emissions, how carbon dioxide concentrations in the atmosphere peak somewhere in the 2040s, and then it starts to decline. So right now, as we are having the seminar series in the early parts of 2021, we still have a choice between these two extreme pathways. Right now, we are unfortunately very, very much still on this low mitigation pathway. And we are heading towards drastic temperature increases towards the end of the century. But we can still make all the choices and take the action to place us on that red line. And we can have a so-called high mitigation future. Now, I will now start to talk about the projected changes in climate in Africa for these various scenarios of climate change mitigation. But let us just start by having a look at that table at the bottom of this slide. If you look at the bottom line, you can see that the projected temperature increase, that is with respect to pre-industrial temperatures, by the end of the century is estimated to range, that it will range somewhere between 3.2 and 5.4 degrees Celsius. So that is, of course, a devastating change for various reasons. I'm going to talk about that. If we should follow the high mitigation pathway, the red line, then of course you can see that the projected temperature increase towards the end of the century is somewhere between 0.9 and 2.3 degrees Celsius. And that is an entirely different world. So let us start to investigate these aspects in more detail. A very, very important investigation on climate change mitigation was, of course, undertaken in the IPCC's special report on global warming of 1.5 degrees Celsius. And the first important conclusion this report reached is that we are currently heading towards exceeding the 1.5 degree threshold of global warming as early as the year 2030. So unfortunately, right now, we are steaming towards exceeding this threshold. 2020, the second warmest year on record, was 1.2 degrees Celsius, warmer than the pre-industrial average. So we will very, very soon spend some time in discussing why the 1.5 degree threshold should preferably not be reached. But let me first just state what we have to do in order to avoid this temperature threshold. These guidelines were also provided by the IPCC special report back in 2018. We have an immense challenge ahead of us. We have to reach so-called net zero carbon dioxide emissions by the year 2050. And of course, that requires immediate action. We already need to have reduced carbon dioxide emissions to a 45% by the year 2030. That is now with respect to the 2010 level. If we give up on trying to avoid the 1.5 degrees Celsius threshold, and we just try to keep the world below 2 degrees Celsius of global warming, then we still need to reach net zero carbon dioxide emissions by 2070. Now, why is it so challenging to reach these thresholds? Well, of course, it's because of the fact that the entire world's economy is still largely fueled by fossil fuels. And if you start to look at the numbers, and these numbers are also provided in the special report, the numbers are staggering. If we want to limit the world's warming to 1.5 degrees Celsius, the investment we have to make in the energy sector in terms of supply and demand measures, so making that transition towards renewable forms of energy, that is going to cost us in the order of an annual investment of about $4 trillion per year, all the way through from 2016, when that specific study was done, until 2050. So that's in the order of $130 trillion investment that is needed. So I think that is enough to make it clear and how tremendous this challenge is going to be to make this transition in time. Who needs to make these changes? Well, the responsibility is shared by all countries in the world. But of course, if we look at the statistics, we can see that in the order of 52% of the world's carbon dioxide emissions, if we count these in terms of consumption, is today associated with the Asian countries. And in the North American countries, we find another more or less 20% of the share in current carbon dioxide emissions. So, of course, without collaboration between North America and Asia, of course, there's no chance of being successful with climate change mitigation. Sub-Saharan African countries, that's quite interesting. Our current contribution to carbon dioxide emissions is still in the order of 3%. If we look at the historical contribution of Africa to the additional carbon dioxide concentrations in the atmosphere, we see that the historical responsibility of Africa effectively for the global warming problem is in the order of 1% or even less. So those are also quite sobering statistics. So what do we need to do in terms of climate change mitigation? Well, it didn't help, of course, when the United States withdrew from the Paris Agreement. That became effective in November 2020. Under the Biden administration, they've already returned, but of course, the United States lost a great deal of credibility in the climate change negotiations process because of these turbulent changes in terms of their own position in the negotiations and in the Paris Agreement. But right now, everybody, you can really start to monitor the news outlets. There is great hope that at the 26th conference of the parties, whether it will happen in November as scheduled, or only in the Southern Hemisphere autumn of next year because of COVID-19, there is great optimism that we will see the strongest climate pact ever at this meeting. So let me speak more about that. This is a headline from today's news. So John Kerry, as the United Nations climate change ambassador, I guess we can say, is currently in China, negotiating, or I would guess preparing or trying to reach some agreement ahead of this important upcoming international negotiations. So the hard reality is that the United States and China specifically will have to cooperate in terms of climate change mitigation if we want to stand any chance in terms of being successful with aggressively implementing the Paris Agreement. Right now, what I think we will see later in this year, or at least at COP26, if maybe it will only happen early in 2022, but all the signs are there that we are going to see a new pact between the United States, Japan, South Korea, the European Union, United Kingdom. These countries will all likely, or they have, some of them have already, make a formal commitment to reduce carbon dioxide emissions to net zero. So no further carbon dioxide emissions into the atmosphere, no net emissions, by the year 2050. And of course, China has already also made strong commitments, but the hope is that they will also be part of this 2050 pact. South Africa, by the way, is another country that has also already made that commitment. So if this is going to happen, and this pact will indeed, remember this pact controls more than 66% of the world's economy, if it's also going to include China. It will change the world in front of our eyes, and the world will be on a path towards renewable energy, a revolution in how we generate energy on the planet. So let's see, I've just given you, I think, the most optimistic take on what may happen. And the last thing I'd like to mention before I'm quickly going to show you some projections of climate change in Africa. I want to point out that also here in South Africa, we do see at our universities a greater and greater awareness about the environment, and specifically also about climate change impacts in Africa and air pollution in South Africa. So around the time that Greta Thunberg made that address to the United Nations Climate Change Action Summit, that was in September 2019, we of course had climate strikes in Johannesburg. At the same time, President Ramaphosa, he made a submission to the United Nations Climate Action Summit, and he effectively presented the idea of a massive just transition transaction in South Africa, an $11 billion investment, effectively about making this transition from South Africa's dependency on its coal power plants towards renewable forms of energy. So if you look more broadly at South Africa's position in the climate change negotiations, and also at the position of the Africa Group, you will in fact find that it is very well informed, in the sense that South Africa's targets in terms of climate change mitigation are extremely ambitious. They are in fact very much aligned with the types of targets we find in the European Union. And also in terms of climate change adaptation, the need for that, there's a great awareness within the Africa Group in terms of what awaits Africa. But on that latter topic, let me now briefly talk about the impacts of climate change. So I think I've now given a very, very brief overview about the climate change mitigation effort. Now, what will happen if it fails, and what will be the benefits if the climate change mitigation effort is successful? Well, in the IPCC Special Report 2018, you'll find, of course, a summary of all kinds of climate change impacts. I would just like to highlight with this slide number, the fifth bar on that slide from the left, reason for concern number 5 in IPCC language. And it shows the so-called risk for large-scale singular events. So what does this mean? This is in the first place about the possible melting of the Greenland ice sheet and the West Antarctic ice sheet. Now, the shocking finding is that the irreversible melting of these two ice sheets may be triggered if the world's temperature reaches those thresholds somewhere between 1.5 and 2 degrees Celsius. So we may likely initiate the irreversible melting of these two ice sheets somewhere above 1.5 degrees Celsius of global warming. Of course, if global warming should increase to levels above 2 degrees Celsius of global warming, that risk will only increase further. But that is one of the main reasons why the Paris Agreement originally was aiming at restricting global warming to 2 degrees Celsius or less. It's to avoid the irreversible melting of these two ice sheets. Now, of course, it will take several centuries for these ice sheets to melt. But if they do melt completely, it will commit the world to sea level rise of about 12 meters. In our own lifetime, or by the end of this century, the sea level rise may be as high as 1 meter. So that slide shows that a big iceberg, 5,800 square kilometers in dimension, it broke loose from the Larsen ice shelf. It was back in July 2017. A single iceberg as big as 1/3 of Kruger National Park, just to give you an idea. So across the world, we of course are seeing an increase in the rate of glacier melt, including from the two ice sheets I've mentioned. And then finally, why is the Paris Agreement trying to restrict global warming in its original formulation to below 2 degrees Celsius? Simply because what is known as dangerous climate change sets in more or less at 2 degrees Celsius of global warming. That just means a step up in the frequency of occurrence of extreme weather events, including category 4 and 5 hurricanes, devastating heat waves of unprecedented duration and intensity, and of course, mega fires. And you just have to turn on the television almost on any day of the week to see these types of events occurring and being reported on across the world. Clear evidence that all these three main types of extreme events are already occurring more frequently. How do we generate projections of climate change for the world and for our region? Well, let me just mention that all these projections are based in the laws of physics. So it's all about applying the laws of nature, the laws of momentum, energy, and mass conservation to the Earth system. So the scientific foundation behind climate change projections is objective and it is solid. Now, we do need very big computers to make these projections. And in the work that we do here at the Global Change Institute, we make use of South Africa's only real supercomputer, the computer cluster of the Center for High Performance Computing of the Department of Science and Innovation to generate these detailed projections of climate change in Africa. No time to go into those details, unfortunately. Now I would just like to conclude, and I will then have some time for questions, by showing you a series of projections of temperature change in Africa and then of rainfall change. And then I'll summarize. We are going to look here at an animation of changing temperatures in Africa. We start in 1971. We are looking at temperature anomalies for a specific year with respect to the 1971 to 2000 average temperature. Blue regions are areas that were cool in a specific year, and yellow regions are regions that were warm in a specific year. So let's start to look at the climate model projection. You'll see first that the model simulates warm years and cool years. Now, the warm years in Southern Africa are typically associated with El Nino events. They are usually also dry, and they usually co-occur with below normal temperatures and above normal rainfall in East Africa. Now, there we are already in the 2000s, and keep your eye on the bottom slide for now. That shows the low mitigation future. You will see that already as we approach today, warm years are starting to occur far more frequently than the cooler years. And you will also see how a pattern of relatively strong warming is developing over time in Southern Africa and also in subtropical Africa, so the Sahel and the Sahara Desert north of the equator. And as we move into the second half of the century, you will see the frequent occurrence of those orange colors, and they represent years that are already 4 degrees Celsius warmer than the 1971 to 2000 average temperature. And of course, you can see as we move deeper into the century, those who have experience with working in ecosystems or agriculture or water security, I think you can already imagine what the consequences of such a drastically warmer world will be in sub-Saharan Africa. So the IPCC, in fact, in its special report in 2018 found that if the world's temperature should increase by 3 degrees Celsius, and the regional temperature increase in Southern Africa is in the order of 6 degrees Celsius, we may well see the collapse of the maize crop in Southern Africa, and also the collapse of our cattle industry. So that is one of the reasons why Southern Africa has been identified as a so-called climate change hotspot. Now that classification also holds for the Mediterranean parts of North Africa. And you can also see on these projections that tropical Africa warms a little bit less than the subtropical parts. And there are certain reasons for that. The top slide shows us that even if we can implement quite a strong mitigation process represented by the green line in that slide, we are still committed to warming in the order of 3 to 4 degrees Celsius in Southern Africa. So this is the last slide I'll show before I'm going to briefly conclude, and hopefully we'll have some time for questions. These are the projected rainfall futures for the world. But I would like to point out to you that pattern of drying over Southern Africa. So the subtropical parts of the world are in fact some of the most vulnerable parts when it comes to climate change. These parts of the world are projected to not only warm drastically, but also to become generally drier. Now we all know that Zambia, Angola, Namibia, Botswana, Zimbabwe, South Africa, these are already countries that are warm and dry. If they become drastically warmer and also drier, it greatly limits what we can do. We say it limits the options we have for adaptation. So I think in the interest of time, let me conclude and say that the main message I'd like to convey tonight is that we have almost run out of time in terms of having a chance of keeping the global temperature increase to below 1.5 degrees Celsius. It's going to be extremely difficult. I've mentioned the mitigation targets that are needed. This upcoming COP26 meeting is really the last chance for a massively strong global mitigation effort based on a new climate change pact. Then we may still stand a chance of keeping the world's temperature increase below 1.5 degrees Celsius, maybe below 2 degrees Celsius. Well, maybe below 1.5, and there's still a better chance of keeping the increase below 2 degrees Celsius. This mitigation effort may well change the world as we know it. It will, if it's going to happen. We need to be extremely careful in Africa of not becoming the dumping ground of the world's fossil fuel technologies, while the rest of the world is making this change. So we are facing tremendous risks here of ending up with stranded assets or with compromised trade deals. But if we will be part of the mitigation process, there are also tremendous opportunities for us to get investments in our region towards the renewable energy transition. If the global climate change mitigation effort fails, then of course in Southern Africa, we will be facing temperature increases in the order of 4 to 7 degrees Celsius towards the end of the century. So it means that we will likely exceed certain tipping points in terms of the sustainability of our maize crop and cattle industry. Imagine Southern Africa without its staple food, maize, or without cattle in, say, Botswana. it will be a different world. It will not be the Southern Africa that we know today. With these increases in average temperature, of course, the projections are for an associated increase in the number of high fire danger days, heat wave days, and so forth. And then the last two risks I'd like to point out are firstly, the first risk has to do with multi-year droughts. The El Nino drought of 2015-16, the Cape Town drought of 2015-17 have shown us how close we are to experiencing so-called day zero droughts in Southern Africa. Unfortunately, as the Southern African climate system warms and dries, the risks for these types of droughts become bigger and bigger. I think that the single biggest risk South Africa faces in the context of climate change is the possibility of a day zero type drought in the Gauteng province. Just think about the socio-economic consequences of such a drought. And then finally, our neighboring country, Mozambique, is becoming increasingly vulnerable to intense tropical cyclones making landfall. The Americans would call those category 3 to 5 hurricanes. I don't think South Africa itself is exempt from such an occurrence. It has happened that smaller intensity cyclones have reached Maputo and even Richards Bay. I don't think we are prepared at all for the possibility of, say, a category 4 or 5 hurricane making landfall at Maputo or moving into the Limpopo River Valley or even reaching Richards Bay. So whether we are going to face a low mitigation future where we will have to deal with all these impacts, increasing impacts in our region, or whether we are going to live through a high mitigation future where we make the transition to renewable energy, the only guarantee is that life in Southern Africa will greatly change. And the best that we as a scientific community can do is, of course, to prepare ourselves and our fellow citizens as well as we can for what's coming. And with that, Diane and David, I hand back to yourselves.
Thank you very, very much, Francois. It's not a nice story you have to tell. It's rather concerning, to say the least. I'm just trying to visualize a South Africa that's so dry and hot. It's just, yeah, day zero, no water. It's, you know, not a, and there wasn't very much hope, it would seem. But thank you again. It was really good. And it's better that we know what we're facing than we don't. So questions then, people, if you could please put your hand up if you have questions, but we'll go through the ones that have been posted. Richard Meissner posted one to you, Francois, and he said, thanks for explaining climate change and climate variability. And he says that European researchers say that they do climate change analysis, but not so much variability. And he says the reason is that one of his colleagues told him that Europe doesn't suffer so much from variability. Is it true that we have particularly high vulnerability to climate variability over and above what you're saying? And perhaps why is this?
Yes, thanks, Diane and David and Richard for this question. Yes, now it is certainly true that in the subtropical parts of the world, where rainfall is under average far lower than in the high latitudes of Europe and United States, the variability in rainfall from one year to the next is indeed significantly higher. It's also because of the fact that Southern African climate variability is so strongly controlled by El Nino and La Nina events in the Pacific Ocean. So Southern Hemisphere climate variability, it's true for us, it's true for large parts of Australia and South America, that's indeed very, very strongly controlled by the 2 to 7 year cycle in the Pacific Ocean when it comes to El Nino and La Nina events. Now, to some extent, this is an advantage. The water managers in South Africa are used to dealing with droughts. Our farmers know how to deal with drought, and there are periods of good falls of rain. So to some extent, our resilience to that climate variability is going to help us into these first few decades of increasing climate change. But a really important question, follow-up question then is, of course, how climate change is going to change that variability itself. And one of the most important messages is that we can affect the more frequent occurrence of these El Nino type droughts. So droughts that last for 3 to 5 years at an end, and that may include one very big El Nino event within that is a major risk. And that is one of the key risks we need to prepare for in a changing climate. Then, as you've said, I mean, many of these projections for our region are grave. Let me first just say that if the Paris Agreement can be implemented and we can restrict global warming to 2 degrees Celsius, then many of these most devastating impacts are avoided in Southern Africa. So there's still a lot of hope in climate change mitigation.
Thank you, Francois.
So that was the global change light-saving system setting in. But I have to move more vigorously. But effectively, effectively, it's as you've said, at least we can use climate science to prepare to some extent for these likely impacts in our region in the case of a low mitigation future. So at least science can help us not to be surprised by these changes that are to occur. But they will certainly be devastating and beyond the limits of adaptation if the world should reach a level of global warming of about 3 degrees Celsius.
Sure. Another question from Richard was that he says that from a political science perspective, addressing this doesn't really only depend on political decision makers, but sort of depends on all of us. These warnings of climate change have been gone back 30, 40 years. And yet we don't seem to have done very much over 30, 40 years. We will be addressing this later, but from your viewpoint, what do you think stops us being more active about this and not sort of doing more to mitigate?
Yeah, no, that's absolutely true. And that is why we are now left with effectively less than 10 years to reach this major emission reduction target of a 45% reduction in emissions by 2030 with respect to the 2010 levels. So we have left this until the very last minute, to put it like that. And I think to a large extent, it is because of the reality that we can't get away from the fact that a strong climate change mitigation effort does require that economies will accept costs on the short term. I've mentioned that staggering number that this transition is requiring an investment in the order of 130 trillion US dollars, 2010 level to US dollars by 2050 to make this transition. So they are the benefits, of course, in the long term by far outweigh this investment, because if we can reduce the global warming to levels of 2 degrees Celsius or less, we will, of course, have significant reductions in extreme events across the world. And in the end, we will save costs from extreme event impacts. But in the short term, economies must invest and must accept costs on the short term in exchange for long-term benefits. And so far, none of the world's big economies have really taken that step. I mean, we do see the first signs now in the European Union. I must say in the European Union, I think a societal tipping point has been reached. And we do see strong reductions in emissions. And there's a likely pathway towards net zero emissions by 2050. But the evidence of the big Asian economies and the North American economies also walking that path of strong mitigation, that remains to be seen.
Thank you. A question from Himla Sudyal, and is if Africa contributes about 3% to carbon emissions, why then does Southern Africa have such a high temperature increase? And then there was a related one from Elma Mabuza. How do we affect our neighboring countries with greenhouse emissions if they don't use fossil fuels for electricity generation?
Yes, so that is the irony of all of this. The carbon dioxide emissions emitted into the atmosphere by the industrialized countries of the Northern Hemisphere, of course, these gases are very swiftly distributed across the entire planet by the world's wind systems. So even a place like Marion Island, where there's never been a factory, is experiencing drastic warming. So remember, it's not Africa's emissions only that is driving warming in Africa. It's the entire world's emissions that are driving the warming across the world, including in Africa. So the reason why our rate of warming is so strong has everything to do with our unique climate system in the subtropical parts of Africa. So it's a manifestation of regional climate processes that is causing in a warmer world that is causing our high rate of warming.
Thank you, Francois. And then two questions which are sort of on a similar topic by Dumisani. It would be very important to collaborate within the South African region to work on adaptation, planning and implementation to avoid the worst eventuality. And from Nicholas King, Francois, could you talk a little bit about implications for migration across and from Sub-Saharan Africa? So I think they're sort of covering similar trends. What are the implications?
Dumisani, well said. What you've just said is so important. In a changing world, Southern African countries and Sub-Saharan African countries will have to collaborate like never before and cooperate in order to adapt to climate change. The regional trade in food, sharing of water resources, the transport of water between countries, and the transport of energy between countries, it's going to become more important than ever before. Helping each other, supporting each other, possibly through joint insurance schemes, collaborating in terms of disaster management. A changing climate system does require significant improvements in how some Southern African countries are going to cooperate in terms of dealing with natural disasters. And then, yes, climate change refugees, what an important problem for Africa into the future. I always thought that the first climate change refugees from Southern Africa or Sub-Saharan Africa may come from Botswana when the cattle industry collapses, because 70% of the people there still has some dependency on cattle, or maybe from devastating flood events in Mozambique. But I think nowadays, I think that the first climate change refugees may be Cape Townians, people that are moving out of the southern coastal cities of South Africa because of more frequent problems with water shortages. At least I think we can say that it's very difficult to see how cities like Cape Town and the larger Nelson Mandela Bay region in South Africa are going to grow sustainably in a future that is becoming substantially drier. So yes, climate change related displacements, climate change impacts on the sustainable growth of African cities. These are some of the biggest problems Southern African governments will have to deal with moving into the next several decades.
Thank you. Then from Tumelo Nlapo, how do I educate school children about this topic?
Well, Tumelo, what an important question as well. Of course, I think climate change is a wonderful hands-on study field. I mean, just think how exciting it is to teach children about seasonality. It's easy to teach children to make observations of, for example, rainfall seasonality during a few years in school. But then one also needs to, except for these exciting aspects of teaching climate or meteorology in school, one does have this responsibility of conveying to the children this important message that they are in fact so young that they will be living through all these changes that we are now projecting as scientists. So it is certainly a sobering message, I think, to convey to kids. I can't really claim any successes in doing that successfully. I have had one or two instances where I literally left school children in tears, unfortunately, especially those that care about the environment and African animals and so on. But I think one needs to convey the important messages to children. We need to convey to them some understanding of the problem. and also convey to them the message that they are in fact the agents of change. Unfortunately, the hard reality is that their parents and the generation currently make the decisions have left us all too late and have not made the right type of decisions in time. But they will be 10 years from now, be in positions where they can hopefully still make stronger decisions when it comes to, for example, South Africa's road to a renewable energy future. So yeah, finding that balance between conveying to them the fascinating aspects of climate change science, and also the responsibilities that come with becoming an environmentalist eventually. That's a delicate balance, and that's maybe the only question I can't answer so well tonight.
Yeah, and your energy saving initiatives, which are
that's right. That's right. That's really the global change has this crazy system at night. I guess no lights are allowed to be on, but anyway, almost there.
You end in the dark. I think we have time probably for two last questions, and these two are related. One is from Celestine Simpuga. Are there any publications on this work we can refer to? And then also asking, I'm trying to find where it was, increasing awareness of climate change within higher education institutes. What else can universities do with the knowledge they develop to assist in societies in mitigating and adapting? In other words, how can us as universities and people in universities inform ourselves and actually apply what we're doing to help?
Yes, so I would say in terms of the latter question, I think there are many universities that are already offering specialized degrees in aspects of climate change. It's a multidisciplinary problem, so it's a wonderful opportunity to also produce students that are skilled across a vast range of disciplines, starting with the physical climate sciences, all the way through to understanding impacts on society. So universities absolutely have the responsibility to produce postgraduate students that are highly skilled environmentalists, that have a sound grasp on the physics of climate change, that have an understanding of the unique vulnerabilities to climate change impacts in Sub-Saharan Africa. And to a very large extent, they have to become adaptation specialists. So adaptation to change, I think, is the biggest name of the game in climate change science in Sub-Saharan Africa today. So as South African universities, we need to produce postgrads with those specific skill sets. I think on the engineering side, given the growth we do expect across the world in the renewable energy sector, there's also a responsibility to develop a new generation of renewable energy specialists in South Africa. It's also about reducing demand. So in architecture, for example, producing students that know everything that is to be known about adaptive buildings and green buildings. These are the types of skill sets that we need to increasingly grow across our universities. I think many universities are already gearing up their offerings in this respect. I think there was another question that I've forgotten now what it was, Diane.
Well, it was, where do we get more information on this?
The starting point to read, if you're interested to read about climate change mitigation, the physical science base about climate change, so understanding why the system is warming up, why climate change is occurring, how to project future climate change. An excellent starting point for this is the IPCC Special Report on Global Warming of 1.5 degrees Celsius. It consists of 5 chapters, and it takes the reader through the entire science base, from mitigation to projections to impacts to adaptation. So that is what I think, if you don't have background in the field, that is a wonderful document to start your reading at.
Thank you, Francois. David, have we got time for one last question, or will Richard have to contact us separately? Are we running out of time?
Diane, well, I think let us allow another 5 minutes.
Okay. Richard, you had your hand up. would you like to ask your question?
Yes, thank you very much, Diana. Good evening, Francois. Good to see you again. Francois and I, we were colleagues at the CSIR. I'm no longer with the CSIR. I joined UNISA on the 1st of February this year. I just would like to say something about the comment that Francois made, or the answer he gave to migration in Southern Africa. While I was at the CSIR, we were conducting a research project on environmental migration, looking at the Limpopo area, and we conducted interviews with migrant workers. And already in that, during those interviews, we did come across people who migrated because of the drought. From Mozambique, some parts of Malawi, and then also some parts of Mozambique. But that was, we need to remember that was during the drought. We conducted these interviews in 2017, 2018. And it is very interesting. It's a very interesting take that you have, Francois, on internal migration, people migrating from other parts of the country to inside a country. But just to say that we've already picked up this migration pattern across borders due to climate variability factors. Thanks.
Thank you, Richard. If I can briefly comment, I can just say, I think that's really important work you've done there. And increasingly, I think we do need more data on to what extent displacements of people are occurring in sub-Saharan Africa when a big drought strikes. Of course, in a changing climate, unfortunately, the science is clear that these multi-year droughts will occur more frequently. So then we can expect that such displacements to the cities, if they are not permanent displacements already, may well become permanent displacements increasingly as we move deeper into this warmer climate where these types of droughts occur more frequently.
Yeah, just to add on to that, our colleague or former colleague, Nikki Funke, she's now part of an international consortium looking at internal migration due to climate change and climate variability. I'm also looking at the Limpopo province. So there's already a study underway by Nikki Funke at the CSIR regarding that.
Well, thank you very much, Richard, and thank you, Francois. We have a number of questions I don't think we'll be able to get to tonight. Busiswe is asking about mitigation efforts in sub-Saharan Africa, and we have Pathmanathan and Lakshmi, excuse me how I pronounce your name, asking about renewable energy. We will be having topic 5, for example, is on renewable energy. We have Irina coming to talk to us. We have government who will be talking to us about their strategies. So we hope through this multidisciplinary set of talks, we will cover some of the questions we haven't got to tonight. Please, I'd like to, before I say thank Francois, just to remind everybody, the next topic is on the 6th of May, where we will be looking at the discomfort of uncertainty and the certain of uncertainty of scientific research. Which perhaps will explain why it is so difficult for business and government to make decisions in the face of uncertainty. So please join us. But what I'd like to say is thank you, Francois, for introducing us to this very difficult topic and this very somber outlook of what we face. But I think it's a very good basis for where we go forward about what we need to do about this and what the barriers are, both real and psychological and business and you know, from law. Why these barriers exist and what we can do about getting around them. So thank you very, very much. We really appreciate you being our opening speaker. And thank you to all our participants who've stayed on past our advertised ending time. Thank you very, very much. Please keep the chat going on Facebook and we'll try and answer it. And let's get an active, committed community going, looking at this, because in the end, the solution to this problem lies not in our individual hands, but in our all our hands together, and we can only address this if we all work together and talk together and understand our concerns and our strengths. So thank you very, very much to all the participants. Hope to see you on the 6th.